Let's try to understand the lesson vectors. Before that, let's define scalars. Scalars are the physical quantity that have only magnitude and no directions. That means they can be very well expressed only with magnitude and no directions required for its expression. Such physical quantities will be called as scalars. Examples are distance, mass, speed, work, energy, heat, power, time, temperature, charge, and potential. All these physical quantities, if we see, they can be very well expressed only with magnitude and there's no need of directions. If we define vectors, vectors are the physical quantities that have both magnitude and direction. That means to express such physical quantities, we require both magnitude and direction. Such physical quantities can be called as vectors. Examples are weight, displacement, velocity, acceleration, force, momentum, torque, electric field, and magnetic field. All these require both magnitude and direction for the expression. Let's define triangle law of vector addition. If two vectors can be represented in magnitude and direction by two sides of a triangle taken in the same order, the resultant is represented completely by the third side of triangle taken in opposite order. If you see here, we have vector P and vector Q. Okay. If you see, we have vector P and vector Q. Then they are taken in same order. If you see, from A to B we have taken P, and then from B to C we have taken vector Q. They are in same order, and the resultant is taken in opposite order from C to A. Thus, resultant of such two vectors are R is equal to P plus Q. You can see here in the diagram. Okay, let's define parallelogram law of vector addition. If two vectors acting simultaneously at a point can be represented both in magnitude and in direction by two adjacent sides of a parallelogram, the resultant represented in magnitude and in direction by diagonal of parallelogram passing through the point. If we see vector P and vector Q, okay, represented at two sides of parallelogram, that is from D to C is a vector P and from D to A is a vector Q. The angle between them is theta, and if we complete the parallelogram, then you see the vector R, that is D, okay, dB. If you see, that is vector R represent the resultant, that is the diagonal. And the formula for finding the magnitude R is given by square root of P square plus Q square plus 2P cos theta, and the direction is given by tan of beta Q sin theta plus P plus cos theta. That beta is the angle between the direction of diagonal and the vector P. I hope you understood.